In this short video, we are going to discuss types of equations that are called polynomials. Now, polynomials encompass almost everything that you have already worked with, but there's two things that stand out to us that tell us that something is not a polynomial. So come over here to notes, please, and we are just going to represent what is not a polynomial. So a polynomial is a type of equation. What is not a polynomial function? So there's two major things that stand out. The first is we can have no negative exponents. No negative exponents. So I'm going to give a quick example of what that may look like that tells us, oh, that's not going to work. So y equals x to the third plus 2x squared plus 5x to the negative 6 plus 1. I'm going to draw an arrow there. Whenever we have an exponent that is negative, it no longer constitutes a polynomial function. The second major infraction is we can never have an exponent that's a variable. So exponential functions don't work. Here's an example. Y equals 2 to the x plus 3. In the exponent position, it can never be negative and it can never be a variable. Those would not be examples of polynomial functions. No negative numbers in the exponent positions, no variables in the exponent positions. Bless you. In each of these positions, I'm going to provide you with an equation, bless you, that's an example of these specific types of quadratic functions. Y equals 6. If you did not realize it, that's the same as y equals 6x to the 0. Please draw an arrow to the 0 and circle degree. The degree for this equation is 0. It's called a constant. When you see no variable, you see just a number, y equals 6, y equals 2, y equals 1/2, y equals -4. There's no variable in the equation. There's no x variable, for instance. We call that a constant. And the degree type would be degree 0. Now, the leading coefficient means what's in front. So for this example, the leading coefficient is a 6. Linear. Linear, by the way, I'm going to write underneath this y equals mx plus b as a quick reminder. Y equals mx plus b. Okay, so y equals negative 2x plus 4. Now, a lot of students say, like, I don't see an exponent on the variable. When you don't see that number, it's a 1. It's a hidden 1. So this is degree 1, and the leading coefficient is directly what's in front of that, negative 2. Leading coefficients can be positive and negative. Leading coefficients are different than exponents that are negative. Okay, quadratic is what we've been working with for the last month. So this is something like y equals ax squared plus bx plus c. It's just a basic, that's a basic standard form of a quadratic function. And here's my example. Y equals negative 1/2 x squared plus 3x minus 4. I'm going to draw an arrow to the highest exponent on a variable. That numerical value is called the degree. So this is degree 2. It represents a quadratic function, and the leading coefficient is negative 1/2. Cubic means degree 3. Y equals x to the third plus 2x minus 1. The highest exponent on a variable is 3, so this is degree 3. It's called cubic. And a lot of students are like, but there's no leading coefficient. It's a hidden 1 in front. Quartic is degree 4. Bless you. Quintic is degree 5. Y equals 5x to the fourth minus 2x squared minus 7. This is degree 4. It is quartic. Quartic. The leading coefficient is 5. Okay, quintic is degree 6. Now, sometimes things are not put in order, and I'm going to give you an example. 3x to the third plus x squared minus 5x to the fifth plus x to the fourth minus 1. So all of these are in standard form. This is an example that's not in standard form. It has not been organized with the largest exponent on the variable first. So sometimes you have to analyze and go, okay, the largest exponent is 5. This is degree 5. It is quintic. And the leading coefficient is negative 5. So right now we're going to start by looking at these two examples. There's no reason for you to write them down. And we're going to identify how many unique terms. Terms represents groups. So first thing you have to do is you have to see what can you combine. All of these are like terms. So I'm able to combine 3 plus 5. And actually, let me change this just to make this a little bit better. 3 plus 5 is 8x. 8x minus 18x is negative 10x. There is one unique term in this expression. Now, when I look at the second example, a lot of students without understanding this would say there's 4 terms. Miss Bradley, I see 4 different groups, but first you have to combine like terms. So x squared minus 5x plus 6, because I combine these two. Here, there is 3 unique terms. These 3 examples, we're going to do 3 things. First is we are going to look at the equation that we're provided. We're going to combine like terms and write it in standard form if it's not in standard form. So I look here, there's no terms that can be combined, but this is not in standard form, so I'm going to rewrite it. Y equals negative 2x cubed plus 15x squared. You're just watching, plus 7x plus 1. Next, in this particular problem, how many unique terms are there? There is 4 unique terms. None of these can be combined. My next question is, what type of a polynomial is this? So this is degree 3, which is called cubic. What is the leading coefficient? Negative 2. Awesome job. Let's look at the next one. My first question is this in standard form? And if you're like, I don't know what she's talking about, standard form means we just organize it so that the highest exponent goes first. So 3, 2, 1, and 0. Okay, so here's 4. Although there's no x to the third or x to the second, we do have x to the first and x to the 0. So this is already in standard form. I'm going to ask you 3 questions you're going to practice with your partner. You're only telling your partner. You don't have to be besties with them to work with them. Okay, first question is, ready? What degree is this? So you're telling me a number. Talk to your partner. What degree? Degree 4. Awesome. Now, without looking at your notes, what term is degree 4? So what function type is it? Quartic. It's quartic. What's the leading coefficient? 3. Okay, here's your next one. So for this problem, first I'm going to combine, and when I write it in standard form, it looks like 8x squared plus 7x minus 6. So now it's in standard form. I can see that there's 3 unique terms after I've combined like terms. I can see the highest degree is 2, and that's called a quadratic function, and the leading coefficient is 8. So I want you to draw this. Circle positive, negative, even, and odd. When it is positive and even, we'll talk about what that means in a second. Here's my stick figure. Positive, even, it means both hands up. The end behavior is both up. Even negative means hands are down. Odd positive means right's up, left's down. Odd negative means right is down, left is up. Okay, so I want you to draw those. We're going to go back and look at 6 problems to show you how this is going to mimic this. Okay, are you ready? So everybody has this down. You ready? Here we go. When I look at example number 1, I see a degree that is 4. Is that real? All eyes up here. Degree is 4. Is 4 considered an even or odd number? Even. And the leading coefficient is a hidden 1. 1 is positive. So this is an even degree and a positive leading coefficient. So come off to the side. Even degree and positive leading coefficient, which means both ends should be up. Look at this. End behavior, both ends are up. Okay, let's look at example number 2. What is the degree? Please call it out. What is the degree? That means the highest value on an exponent. 3. So is 3 even or odd? So it's an odd degree. Okay, good. And the number in front, is it positive or negative? So I'm looking at odd degree with a positive leading coefficient. Okay, odd degree, a positive leading coefficient means the right side is up and the left side is down. We only care about the end, so I cover up the middle. Does everybody see how the right side is up and the left side is down? Okay, we're almost done. Keep with me. Let's look right now at example number 3. What is the degree? I'm going to zoom in here because it's hard to see. What is the degree? It is what number? 5. Is 5 even or odd? Ooh. If that's okay, who cares if you make a mistake? It is odd degree, and then we look in front to determine is it positive or negative. The number in front is, so I'm looking at odd degree and negative. So odd degree, so up here, odd degree and negative is right here. Odd degree and negative is right here. Right side down, left side up. Right side down, left side up. Okay, we're going to do 2 more. Let's look at example number 4. Example number 4, what is the degree? Is 3 an even or odd number? So I have an odd degree, and the number in front is a positive or negative. So look at your paper. What should happen if it's odd negative? Right side is what? Let's look. Odd negative. Okay, I got to find this. Odd. Okay, I got to find this. Odd negative is right here. Right side down, left side up. Right side down, left side up. Okay, let's check. Right side down, left side up. Okay? Okay, you ready? I'm going to cover this up. With your partner, I want you to look at example 5. I've covered up the actual graph, and I want you and your partner to decide, is example 5, first look at the degree and say, is it even or odd, and then look at the leading coefficient to determine is it positive or negative. Ready, get set, and go. So if you're confused, here's what you're doing. You're like, okay, the highest number on an exponent is 6. So I ask myself, is 6 an even or odd? You don't say it's a positive or negative. Is it even or odd? It's even. So I have an even degree. And then I look in front and go, oh, 3 is positive. So even positive, look at your paper. What does it look like? Look at your paper. Even positive. What happens? Both sides are? Okay. Are both sides up for end behavior? Yes, we do not care about the middle. We're looking at the ends, okay? Last one, and then we are moving on. Here we go, last one. What is this one? To yourself. What is this one? To yourself. Jarrell, help me out. Is this even or odd? How do you think it's even? Why do you think it's odd? Okay, so degree is 5, and he says 5 is an odd degree. Now tell me what else you know. What's positive? The 2 is leading coefficient. I'm finding odd positive. Okay, look at your paper. What does odd positive look like in your notes? The right side is up, the left side down. Is the right side up and the left side down in my example? Yes or no? We don't care about the middle. It's the ends we care about.